So now let's check out the second reversing example. Again, we can just run radar on this one. But I'm going to give you a couple of tips. One of them is you can always use file command, at least on Linux, to determine what type of file something is. In this case, we have ELF 64-bit LSB shared object, dynamically linked SHA-1 hash, and it also tells us that it's not stripped. For this presentation, I'm not really going to explain that too much, but if you see ELF 64-bit, that means it's a 64-bit Linux binary, and that's pretty much it. We can also use strings command, and it will try to get all strings from the binary file, or whatever file you provided. Here, I think we can actually see that the correct answer is, again, this is perhaps secret. Let's just try it out. This is secret, and it's indeed correct. If we test something else, it's going to tell us that it's wrong. But this is a bit different from the earlier one, if we actually look at it. So if we run radar, let's go to the main function and print bytes in there. We can see that we don't have any kind of string compare, at least not that we can see. We only have two function calls within here. One is put, which is basically a printf. Then we have something called cont check. The only comparison we can see here is right here, and this is the wrong number of arguments thing once again. So what we can actually do, see what this function really is, what's in there. How do we do that? In the same way we found our main function. Let's paste the name of the function. As you can see, our prompt has changed. PDF, let's print out. Now we are in the cont check function. And this looks a bit weird. These are perhaps this is secret string that we saw earlier that actually worked as well. And here we have our string compare. So we can actually make multiple functions. As you heard earlier in this presentation, you can make as many functions as you want. We could hide those characters one by one in different functions or in a different way so that we couldn't see the answers so easily. There are multiple things that we can actually do to make it harder to reverse these. Just because these are examples, it doesn't really matter. So here's also the string for correct and wrong. Then we seem to have one no operation. And then we leave return. But what we can now do is we can actually patch the program as well. Let's try that one. Because I want that whatever I give as an argument, I want it to say correct. So how do we do that? Well, with radar, for example. We can open the same program, but in this case we will open it in write mode. So with the W flag here. Press enter. For S main. Let's see how it looked like. Okay. Let's go to this function right here. Cont check PDF, and here we have our comparison, and this is correct. So we want to end up on this line somehow, on this memory address. How do we do that? Well, if we go wrong here, we go from this jump. So if we force this jump to be on the next memory address, we should, in theory at least, always get correct, whatever we give it. Let's try that. So copy, paste, let's go there. If you just copy and paste the memory address, or type one yourself, it will just go to that memory address, as you can see from the prompt. So now we are here. We can WA, you can also find these throughout the question mark menu. So WA is write opcode separated by so on and so forth. And WX would be write to Intel knobs. So we can write hex or we can write assembly. But in this case, let's say PDF again. We just want to write assembly. So we're on 6CA, which is over here. And I want to write, it says jump if not equal, and we will go there. You know what? Let's make it unconditional jump. So JMP, and then let's take this memory address. So 6CC. Let's put in OX 6CC. Press enter. Written 2 bytes. Okay, PDF. And this is how it actually looks like right now. So we test if our string compare says that our strings are equal to the secret string. Then, based on that, we take or don't take a jump. But in this case, we have an unconditional jump that we will take nevertheless. So whatever this returns, this string compare, we will take this jump. Where will we jump to? Right on the next line, so we would get the correct text. Let's see how it works. Then just quit. Let's run the program. Without arguments, it says that there's wrong number of arguments. Let's put in this is secret. Correct. Let's put in test. Correct. Anything we put in, it also always says correct. So now we have patched or cracked this software. We can also run it in a debugger mode, which is R2D, as in debugger. Let's run it. And now you can see our prompt looks a bit weird, because now we are actually running the program. Before, we just looked at it, but we didn't actually run it at the same time. But now we are actually running it as well. But same rules apply. Let's put in 4 A's. S main, I want to find our main function, PDF. Let's print it out. And here is our main function. On the debugger version, we can actually put in breakpoints. Let's put a breakpoint there. Debug functionality is often under the D menu. So D, question mark, then we can see db, breakpoints commands. Let's look at that one. db list breakpoints, db main, add breakpoint to main, or db and address to add a breakpoint to a specific address. Again, let's do PDF to get it up here. Then db, I want a breakpoint right. Let's put it here, right here, copy and paste. Press enter, PDF. Now we can see the small B character right here on this line, and that means that there's a breakpoint there. When you go DC, which would be debugging and continue, hit breakpoint at and the memory address. Let's put in PDF, and now we can see our instruction pointer, which we talked about earlier. So we have this instruction pointer, and this is the next instruction. Rather, this is the next instruction, but this line is what our processor will next execute. But we are in control. So we control what our instruction pointer points to, because we can change that value. Next, we have the wrong number of arguments. We didn't give it any arguments when we run this with the debugger. So we will hit this wrong number of arguments and it will put it out to the screen, and then we'll just leave and return, right? But I don't want that. I want to take this jump even though I didn't have right number of arguments. I want to go right here. Okay. Let's copy that. So dr RIP equals that memory address. Enter. PDF. As you can see, we are right here now. So this is the next line that will be executed. Let's go here. Copy and paste. PDF. This is the cont check function. Then I want the breakpoints right here. db copy and paste, enter, PDF. Now we have a breakpoint there. Let's dc, hit breakpoint, PDF, and here we are. Next we are going to call the string compare. But I just want it to be correct. So let's again dr RIP equals, let's put it here for example. No, let's put it here. Copy, paste, enter, PDF. As you can see, our instruction pointer is now pointing here. DC, enter, and it will print out correct. Our prompt has changed majorly because we have now exited the program. And we got the correct, even though we didn't even have an argument to compare to. But yeah, that's what I have for you today. Thanks for joining me. Hopefully you learned something. And there are also some assignments for you to do if you'd like. There are some easy examples, different ones from these of course, but feel free to try them. Those are all 64-bit Linux binaries made with C programming language. If you'd like to try those. You can use a virtual machine, you can use your own machine if you have one. There are also many examples on the internet you can download and try. They are often called crackmes. I will give you some links for safe ones that don't actually contain malware or anything like that. And you can try those. Some of them are really hard, some of them really easy. It gives you great practice to do so. Anyway, that's it for me. Hope you had fun scratching the surface of reverse engineering. Hope you learned something. Goodbye for now.